Hello guys, looks like we have new kid on the block. So this is the same hype, which not was the hype thing, and looks like they released new version of hype power bank. Yeah, it's interesting. Actually, for the same amount of money, you got twice the battery capacity. So this one is 4400 milliamp hours. Obviously, I immediately picked it up because it looks interesting. So let's take a look what it is. So I think I already figured out how to open it up, and it looks like it's pretty simple, like this. I don't know if the bottom one will go too. I hope we're not gonna break my nails or something. No, it doesn't go in. Okay, well, top one is open. Oh, now we have screws. This ugly hole. Let's quickly unscrew it. So this one is more complicated because now you have a bunch of screws which you have to unscrew. Like the previous version was just like a one can with one screw top or screw back. You just open it up, slide the battery out, and it's free. Here we have screws. So this is a little bit more solid design. Obviously this is the fall panel, like, which is just mostly for aesthetics. I already see two batteries, 1 and 2. Probably this side will pop, like, yeah. Oh, this side was actually screwed. Oh, nice. Oh, okay. It's not coming out easily. Don't know why. Okay. So, oh yeah, here we are. Here we are. Okay, so the top part is snapped on and the bottom part is screwed in. Okay. Ta-da! Here we are. It's probably pretty much the same generic batteries as we saw in the previous version. I don't know if you have it somewhere lying around, but that's really the same. CJ brand generic batteries. Pretty much very similar build design. Let me find the original hype and we will take a look side by side. So here we are, here it is, side by side. This is the hype version 1, or a one cell hype 2200 milliamp hours, and this is 4400. Okay, let me zoom in. Okay, here we are, a little bit closer. So as you see, it's very similar, like just judging by the number of components, and you can see it's very similar component base. Maybe actually no. So this one component is different, but that may be it has to be, because you have two batteries, you have to like have a balancing and protection circuit for two batteries. So that's might be it. I will take a look closer to see what actually kind of component it is. Just to understand, but these two are the same as in this design. I like to also pull it out of there and see what's on the back side of this PCB. Okay, I'll remove that for a second. And on the back side we have a whole bunch of unpopulated stuff. As you see over here, they have a tactile button over here, which is obviously gonna power it on and off. I kind of like this board design better than like in this version. So this one is more massive. Obviously, it can handle like a temperature and current load better because it has this big traces. So it's kind of nice. Oh. Those look like LEDs over here, aren't they? 1, 2, 3, 4, nicely spaced LEDs. So essentially, it's going to indicate the charge. But if I look, oh, nice. Now I see 1, 2, 3, 4 holes. So there is four holes over here. I thought this is like a solid black plastic, but it's probably not. It's something translucent or something, and it's gonna show through this button the charge This is even better. I like this. I like this power bank. Well, what I don't like, it's actually came dead, so I cannot even demonstrate it for you. So let me charge it and continue this video after here. Oh, so here we are. So after 13 hours plus of charging, this battery bank is finally charged. It was, for some reason, it did not accept current more than 240 milliamps, so it was charging for about 13 hours, so it was completely empty. So now it is full, and when I tried to charge a cell phone with this and could not charge with current higher than 850 milliamps. So I don't know, maybe it's this supplied cable limitation. Maybe it couldn't push any more current through this thing and just was a higher resistance. I didn't try any better cable, but anyways, I will do separate test on that one, on any other cables which actually come with it. But that could be a cable problem. So this thing is actually now fully charged, and I can show you how LED works. So in order to have to hold for a while, and now we have LED. So LED is not super bright, but there is something that can clearly help in case you need a little bit of light. Well, cell phone can produce a lot of light as well, but this is good to have. So this is cool. Also want to admit that lights over here are pretty bright. So I was complaining that my complaint would be that when it's charging, it would produce a lot of light and it'll be like, brightening half of the room. But I did realize then that actually when you have this like over here, it's barely going to be seen anything, because this is pretty thick, some sort of bluish plastic, and it kind of cuts a lot of light. But on the other hand, like, why would you have LED so bright and pissing away energy during charge? So also I want to admit that this battery was charged. I was using my meter in order to see how many milliamp hours at 5 volts was put in into this power bank. So it was roughly 3400 milliamp hours. So I assume actual capacity not even close to 4400 as they claimed, because when you look into components, let's go over components. So probably the most important part is the batteries. So these are Changjiang brand, how much as I can research, and this is supposed to be 2200 each. I don't believe they are 2200 each. Actually, I think they're like close to like, I don't know, 1400 or something, 1200. So I have to actually do particular test on the batteries when I like take it out, but no way it's gonna actually do 2200. But it's remained to be tested, so this is I don't have information on this one. Also, let's look at the component base over here. So we have few passive components, not as many as I would expect in comparison to other power bank and power bank controllers. For example, this one, if you see, can have it has much more active components over here, like little chips and whatever. Maybe some of them are MOSFETs and things like that. I didn't look into details what are here, but over here we have so this guy over here is IP5306. This is a charging controller. It also drives those LED as well. So essentially this LED shows was the charge level of the battery, or the capacity remains in the battery. So these two are dual MOSFETs, but there are two dual MOSFETs. It's I think one is usually enough, but this is they are used in battery protection circuits. And this guy over here is battery protection IC. So in typical schematic of this one, which is DW01A, there are always used one dual MOSFET 8205A, which is this guy. But here are two, so I assume they are just, you know, beef them up just to have more, you know, switching power or something. But that's what we have. Inductor and a little bit of passive components around, and that's pretty much it. It's very simple PCB. There's a whole whack of unpopulated components over here. I do not know what they are for. I didn't analyze this or anything like that. So there's yeah, quite a bit of unpopulated stuff. Even one transistor over here, Q1, a bunch of resistors and capacitors. But yeah, I guess just some cost-saving stuff. Also over here there is LED, but I think it's just driven very in a simple way through current limiting resistors, and pretty much it. And I think I didn't really look too far, but clearly it will be driven through this chip, and because the button is connected to the chip as well, which actually powers on and off the circuit itself. What else I can say about it? the one something worth noting here, that batteries are connected in parallel, and two batteries are charged simultaneously through one lead, and another lead goes to negative. So that means that this battery is supposed to be pretty much equivalent. Otherwise, there will be some kind of, you know, disbalance in charging. So I believe this is prone to failure, this kind of design, because if there is a differences in these batteries, eventually this will even up, exacerbate, and one of the batteries will fail eventually. I do believe that. So this is what we have, is this power bank. I think it's much simpler than looking simpler than this one, and for the same amount of money, having double capacity, LED indication and little LED flashlight, I think it's totally worth it. So if you had chance to buy single one from dollar store or double one, obviously go for double one, because clearly it's going to be double capacity, and clearly there is a little bit more functionality. Well, it's not as portable, obviously, but I mean, that's not much of a difference. I will do capacity test on this thing in details, and I'm gonna post my results as well as actually comparison to, for example, this battery. I have actually some more acquired from dollar store, which I'm gonna run some tests as well, and compare all of these and see which one is the better, because all of them cost essentially the same amount of money. Also, I would like to actually find somewhere on the internet those schematics of these charging controllers, but you know, it's pretty much crapshoot, because I do believe there's so many of them that actually find specifically this one or that one would be not easy unless I just go and trace it. And I believe this is going to be easier to trace because it has less component and much bigger PCB. Alright guys, this is pretty much it for now. Thank you for being with me, and if you like this video, please like, and please subscribe to support my channel. Thank you, see you next time.